Grade 12, hello again guys, hope you are doing well. Today we'll start with a new chapter, chapter 7, first section in chapter 7. Chapter 7 for circular motion. At the first semester, we knew that we have motion in one dimension. Like if we have an object here and we have a straight line or straight path, we have a distance here. Distance must be in meter and we have a time through a time, so it's in second. And the velocity it was, or the speed, equal to distance divided by time. Distance with meter and time with second. That's mean the velocity equal to meter per second. The unit, the standard unit for the velocity or for the speed, it's meter per second. But today we'll start with a circular motion. First of all, in circular motion, we have tangential speed or tangential velocity. It's Vt. So for example here, we have a circular path, we have a car moving a circle. That's mean at each point, at any point here on the circle, we have tangential speed. So, tangential speed depends on the distance from the object to the center. So again, it's a distance, it depends of the distance between object and the center. That's mean it depends on r. So the distance from the object to the center is the radius. So it depends on r. So first of all, it depends on the distance from object to the center of the circular path. That means it depends on r. When the tangential speed is constant, the motion is uniform circular motion. So again, we said before, in one dimension, we have a velocity. Velocity in one dimension. It's equal to distance divided by the time. Then we said we have acceleration A. And we said before, the acceleration A is equal to the velocity divided by time. So velocity is equal to changing in distance, or its distance divided by the time. Then the acceleration equal changing in velocity divided by the time. And we said before, sometimes we can write like A equal Vf, the final velocity, minus the initial velocity divided by time. So delta D, distance divided by the time, it's velocity. Delta V divided by time, it's acceleration. Again, it was a motion in one dimension only. Now in circular motion, still we have acceleration, but we have two types of acceleration. First of all, the acceleration has three options or three cases in motion, in one dimension motion, in a straight line. If we have a constant velocity or constant speed, the acceleration was equal to 0. Why? Because since the velocity constant, so Vf equal to Vi. That's mean Vf minus Vi equal to 0. 0 divided by time is equal to 0. So when we have a constant velocity, the acceleration equal to 0. Now, if the car is slowing down, that means the acceleration must be negative. If the car is speeding up, that means the acceleration must be positive. So again, don't forget, motion in one dimension, if the velocity constant, that means the acceleration equal to 0. Now my question, when we have a constant speed, if we have constant tangential speed, so here it's constant, does that mean the acceleration equal to 0? Yes, if we are here in a motion in one dimension, a straight line. But in a circular motion, no, it's not. Still, we have acceleration. Why? So as we said, the acceleration depends on velocity divided by the time. So the acceleration depends on the velocity. Now we know that the velocity is vector. When we have a vector, that means the vector has magnitude and direction. Here the motion in straight line, the direction constant because it's a straight line. Since the direction is a constant and the magnitude is a constant, that means the acceleration equal to 0. But when we have motion, circular motion, here, here we have a circular motion. Even the magnitude for the speed or for the velocity constant, but the direction it's not constant. So since we have it changing in the direction, that's mean we have acceleration. Even if the velocity is constant, but we have acceleration because we have changing in the direction. So we have centripetal acceleration. Now we have two types of acceleration. First one, centripetal acceleration. As we said before, when we have a constant velocity, but still we have changing in the direction, that's mean we have centripetal acceleration. Now the centripetal acceleration is equal to v squared divided by r. So v squared divided by the radius. It's a question why we have centripetal acceleration. So it's due to change in the direction. Since we have changing in the direction, that's mean we have centripetal acceleration. The second type of the acceleration, so here we have A and B. For example, for A, you have VI and VF. Again here we have VI and VF. Delta VF and delta V, that's mean VF minus VI. Here we have delta V. All the time the delta V must go to the center. So all the time the direction for the centripetal acceleration toward the center of the circle. So here's important note, centripetal acceleration is always directed toward the center of the circle because delta V, that's mean the direction for VF minus the direction for the VI, all the time must go to the center of the circle. So we said again that centripetal acceleration results from change in direction. We have the second type of the acceleration, tangential acceleration. Here we have two important notes. So to understand the difference between centripetal and tangential acceleration, we assume that we have a car traveling in a circular track or circular path. First of all, because the car is moving in a circle, that's mean the car has centripetal acceleration. So centripetal acceleration, even we have a constant speed, constant velocity, but we have changing in direction, so we have a centripetal acceleration. Now, if we have changing the speed, so the car speed changes, that means we have a tangential acceleration. So tangential acceleration results from change in speed. Centripetal acceleration results from change in direction. Thank you guys. See you in, I think it's enough for this session. So see you next session inshallah. Good luck.